Everyone, up until now we've really only looked at linear or arithmetic sequences and geometric sequences separately. So now we're going to combine them, and basically this is more real life application of the sequences, because when you think of getting a loan, you do have to repay that loan, so you're making payments. So it makes more sense to have both a geometric and linear component of your sequence. All right, so we've got a bit of theory to get through. So what I think I might do is go through all the theory in this video, and then in a second video relate it to some questions. So just explaining these posters in this video as best as I can. All right, so we're focusing on, with additional payments, three main financial applications. So I might just get my little highlighter. So we have investments, loans, and they're called reducing balance loans, and we have annuities. And I've got perpetuity there because a perpetuity is a special type of annuity, which I'll be, I think, also discussing in this video. I think it's on these posters as well. Now, when we're looking at making additional payments, it's extremely important as to what is happening with those payments. So if the payment is going towards the bank, all right, and we're just going to keep sticking with the bank as opposed to thinking about different financial institutions, then your payment goes on your calculator. All right, so this is all to do with the financial solver. Your payment, PMT, so on financial solver it's PMT, is negative, and your investment goes in as negative. I might just scroll down because I did another video here. It's always hard to think of what order do I do these in. So I might just show you here with the financial solver screenshots. So we've got Mr. Richman down the bottom. He's going to invest some money into the bank. All right, so his money is going into the bank, and when it goes into the bank, think about it's coming out of your pocket, it's going to the bank, so your principal value is negative. All right, so when it goes from you to the bank, it's negative. I'm just going to turn my phone off. Don't worry about the payments or anything like that. We're just going to focus on just what is happening. Now, if it's coming out of the bank, all right, so this time it's going and it's becoming a loan, it's going to be positive. So when it comes out of your pocket, goes to the bank. So if you're making an investment, it's positive. If it goes to the bank into your pocket, so it's like a loan, then it's positive. Annuities and perpetuities are slightly different. So I'll talk about them in a bit more detail later, but basically just investments, just make sure you've got a negative, and loans are going to be positive. All right, so let's go back here. Lots of arrows of what's actually happening, but this summarizes it quite well. So your investment, your principal value or your present value is negative, and your payment is negative. All right, everything is going from your pocket to the bank. All right, it's minusing it from your pocket and it's going to the bank. Now, a reducing balance loan, your principal value or your present value is positive, all right, because you're getting that money. You're like, woo, I can go on a holiday now. I've got lots of money. All right, but then you have to pay that money back to the bank, and because it's going to the bank, it's negative. All right, so you can see investment, PV is negative, reducing balance is PV is positive, but both of them have payments to the bank and they're negative. So in terms of an investment, you might be saving some money, so you keep putting money into the bank. Reducing balance loan, you get money from the bank, but your payments to repay that are negative because it's going back to the bank. Then an annuity is slightly different. So an annuity is a type of investment. So that's why your present value is negative. So you're investing money in the bank, but then the bank gives you back that money over a certain period of time. Now, most of the pictures I use to represent an annuity are of old people retiring. So if you think about superannuation, or you probably don't think about superannuation, but the purpose of superannuation, when you start getting a job, the company you work for, your employer, will put money into super. So when you retire, you get that super back, not in a lump sum, but you get a bit at a time. All right, so that acts as an annuity as well. You don't have, super is an example of an annuity, but there are other examples. So maybe, let's say a football club has an annual award, and that has a financial component to it. So maybe a past member has said, all right, here's $100,000. I want you every year, the top player, to get $1,000. And that will come out of that annuity. Okay, so so things like scholarships and that, the funding for that would often come from an annuity. And more specifically, a perpetuity. So without going into too much detail of a perpetuity is an annuity, but the value of the investment never goes down. All right, we'll explain that. I'll explain that later on in this video. All right, so basically we're still looking at compound interest. Okay, so we're kind of getting away from simple interest. We're just looking at compound interest now. So the compound interest, if we just go down here, all right, so remember we have our common ratio, but this time we have our additional payment. So we've got that plus that common difference. So here are your recurrence relations. There's no rules for these because it just won't work because you're adding it each time. It changes each time, but you can have a recurrence relation. So the first one here, we've got investments. All right, so just taking note. Same recurrence relation. We start off with the principal. Remember, you might see the starting value or might see initial value. No consistency from your textbook, but it's all good. And we're just putting in R, which is your interest rate. Remember, it's calculated using that formula. And D is your repayment made. So that's for an investment. This plus and minus business, all right, is different to your calculator. So if we go here, investment, your payment is negative. That relates to what goes into your calculator, not for your recurrence relation. So if you're thinking, why is it positive here and negative there? All right, so that's for your financial solver on your calculator. All right, reducing balance loans, okay, because eventually you want that loan to go down to zero. So that's why you're minusing, you're making payments. And then your annuity is the same. So you're starting off with an amount, but over time that, even though it's an investment, the annuity is giving you back money, kind of like superannuation. All right, so yeah, they're the three different types of recurrence relations. So just make sure you are taking note of these headings. All right, you just don't see this page and choose one of the recurrence relations. Make sure it's the right one. And the same as when you do it on your calculator, that you get the negative and positive BISO correct. All right. All right, so we kind of looked at this before. Let's look at it a bit more detail. We'll start off with the investment. So I'll just explain what's happening in this financial solver here. When we do some questions, I'll talk more about the financial solver. So this 120, that's the number of compounding periods. So, this 12 means, tells me it's monthly, but you don't really need to know that. You don't have to ever interpret a financial solver. But the PY and CY is just payments per year, compounding periods per year. So that's monthly. So that means 120 payments. So that's the same as 10 years. So 10 years of 12 payments, that's where the 120 years come from. Your interest rate is 4%. What you put into your calculator is always the annual percentage rate, so you don't need to divide that by 12. The good thing about your calculator is it's good at calculating things, so it will actually calculate the monthly interest rate for you. PV, remember, he is putting his money into the bank. So he's putting his $100,000 into the bank, so it needs to be negative, and he's making repayments of $500 per month. All right, so that's negative 500. Tells me it's $500 per month. So after 10 years, he ends up with this amount. So he's doubled his money and then some. So let's say he was saving up for a house, although he looks like someone who probably would have a bit more money than that. I don't know. Yeah, so the important thing here is to think, well, this is compound interest, the power of compound interest, and the importance of making repayments or payments. Things increase quite, I don't want to say dramatically, but significantly over time if you add things to compound interest, and a sizable amount. It's no point in just putting in $1 or something like that. All right, and then when we're looking at loans, so money is coming from the bank into your pocket. I've put a house there because a reducing balance loan is basically a mortgage. A mortgage is a reducing balance loan, I should say. Your principal value is, don't want to cross you out. Principal value is positive because that money is coming into your pocket, and any repayments on the loan are negative because that money is going back to the bank. So the initial money goes in your pocket, but your repayments go back. Now, the way I have calculated this, so I thought let's stick to monthly because that kind of makes sense. So this is for 30 years. All right, so 30 times 12 gives you 360. And most mortgages are over 30 years. Now the interest rate is 5%, which is a bit lower than what it is currently. I'd love to have my mortgage rate at 5%, but anyway, let's say after the 30 years, future value has to be 0. I need to have repaid that loan. So this is the amount I'd have to pay each month. So just under $2,684, or just over $2,684. and 11 cents, I guess. So if I made that repayment each month, then after 30 years, I now own my home. Yay. And you're old and you probably want to sell and get something smaller, or I don't know. But yeah, basically just remembering how the financial solver works and what is negative and what is positive. All right, let's just scroll on. So annuities and perpetuities. So again, I'm sticking with the old people with their, because, they save up lots of money and get to have a great life in retirement. So just on the left, I've got the annuities, and on the right, the perpetuities. All right, so the main difference between the two, so you get an ongoing payment from both of them, but in an annuity, you get that ongoing payment until your investment is $0, so until all the money has gone. Whereas a perpetuity, you get an ongoing payment forever. So if you started off with $100,000, that $100,000, you never go below that $100,000. So you basically only get the interest back. So that $100,000 is earning interest, and that's what you might live off, or that's what you a school might use to fund a scholarship, things like that. All right, going back to an annuity, receives an ongoing payment till the future value is 0. Just said that. A perpetuity is a type of annuity. All right, so they're not really two types of things. An annuity is the umbrella term, and a perpetuity is just a type of annuity. The thing is that students often have trouble getting their head around perpetuity, and it does turn up on an exam nearly every year, or it does turn up quite frequently, maybe not every year, but it does turn up. You just need to know that and I probably don't want to highlight it in blue because it's already been highlighted in blue. The investment never decreases. So your principal value or your present value is always equal to your future value. All right, so they go in as the same thing, right? Future. Combining the two words there. Your present value and your future value are equal. So your payment that you receive is from the interest earned on the investment. So let's say these two ladies, they look like they live in New York, have lots of money. They may have invested $5 million and they're having a great life just living off the investment. So the $5 million stays in the bank, and they're just loving life, living off the interest, I should have said. All right, so let's have a look at this example, just comparing the difference between an annuity and a perpetuity. So we've got $150,000 is invested for 10 years, earning 5% interest per annum, compounding monthly. Okay, so the number of time periods, our N is the same. So both are going for 120 months. All right, so that 120 comes from the 10 years times the 12 months. And this is where we need to also put in our months, so 12 months in a year. Our interest rate for both is 5, and for both of them we are we've got negative 150,000 because it's going into the bank. Right, it's still going into the bank. Annuity eventually gets to 0. Okay, so let's say this couple up here, we're doing that, and they think, oh, you know, we're 95, we've probably got 10 years to go. Let's live off this 150,000. So they get $1,500, or basically $1,591 per month to live off, which isn't that much, but anyway, maybe they're subsidized by a pension or something. Now, looking here, our future value and our present value are the same. Now, it's positive here only because that's coming back to you. So if you ever wanted it, it is yours. It can come back to you as positive. But your payment is less. All right, and it's less because you only receive the interest. All right, I hope that makes sense. So you're only receiving the interest. You're not taking anything from what you invested. So after the 120 months or the 10 years, maybe this couple here in New York think, all right, we're still alive in 10 years. Maybe they're a bit younger, maybe they're 60. So let's just, live off maybe not live off, maybe that $625, they throw a party each month or something. All right, so just the main difference between an annuity and a perpetuity. Now, it's not a huge part of the course, but it, to me, should be an easy mark. All right, it's just a definition thing. So understanding the main difference between an annuity and a perpetuity. All right, guys, so in another video, we're going to do some questions, but yeah, see you later.